talk is on censorship. And it's Oliver Barnett, is that right?
That's right.
Right. From Oxford is going to tell us a bit about censorship.
So I'm Oliver Farnham. This is a bit of work I did with Just Right at the Oxford Internet Institute and Alex Dara with me at the Cybersecurity Centre. And this is our method of finding censored content using search queries. So we've done quite a lot of censorship research in the past. We've done things like censorship-based anomaly detection, analysis of censored material, looking at how censorship systems work in real life and how they change over time and with regional variation. And so this is kind of addressing a problem that we came up for in that. So in this paper I'm going to kind of introduce you to that problem. I'm going to introduce our framework, which is kind of a general framework for dealing with that problem, show our implementation, and then show you some of the results that came out of that. So internet censorship happens all over the world. It's not just, we tend to think of it as this big kind of political censorship stuff that happens in other parts of the world. All countries seem to censor to an extent, whether that's political or religious, or whether we're talking about pornography and piracy and stuff like that. And the thing about censorship is, as well, there's very few kind of off-the-shelf solutions. Most countries have a bespoke solution in a way, so when you're doing censorship research, it often tends to focus on one country or another, and broad systems that can be applied to a lot are more difficult. As well as the kind of subjects that are censored, there's also a lot of variation in the techniques that countries use to censor. So the top three here are most common. So DNS poisoning is obviously quite easy, same with IP blocking. HTTP filtering is a bit more difficult, but it gives you a lot more granularity than the first two. But of course, we're all in networking, so there's lots of ways to kind of observe traffic and block it, and so there's almost as many solutions as there are countries. In fact, there's probably more so, because most countries often have got several different layers of filtering taking place. So the problem we came up with is it's not actually easy to find lists of censored content. So even when we're looking recently at China, and China is probably the most well-studied censorship system on the planet. There's lots of work there. Still, there aren't really any big comprehensive lists of censored material. So there are times when you're doing this kind of research and you think, hang on, well, why not I just compare it to this nice list of this? Oh no, there isn't a list. So it's quite, but there's nothing like that in place. Censored systems are generally closed systems. The guys who introduce them, they're not kind enough to say, hi, this is my system for blocking your work. It works this way, and these are the things we're blocking. I think the assumption is kind of security through obscurity, and we don't want this information out there to make it easier to get around. But yeah, so a lot of this kind of censorship research is kind of inferred network measurements. We send stuff, we see what comes back, and by that we work out what they're doing and what they're blocking. And so the current lists that there are, there have been some kind of academic attempts to kind of automatically identify censored content, but they're quite limited in the amount they find. So the lists people use tend to be manually curated. So they're kind of, we know this site is blocked, so we'll add this to the list. And there are some problems with that. Obviously, it's slow, it's not scalable, it can't deal with large amounts of sites, but also censorship tends to change over time. It's very rarely static. Something might be blocked one week and then it'll be unblocked the next. So yeah. So to deal with this, we kind of wanted to come up with a more general approach that we can apply to lots of different countries and lots of different systems, and kind of automate the generation of these lists. And we were thinking, well, okay, you know, why is people trying to do this heavy lifting themselves when somebody else is really kindly crawling and indexing all of the web for us? So I'm, of course, talking about search engines. Search engines are constantly going through, indexing pages, indexing their content for things like keywords and material on there. And so it makes sense to use this as opposed to trying to implement our own system to try and find these censored material for us. So this is kind of our general solution, and this is what we're proud of, but of course this isn't really that interesting on its own, so we had to build the thing. And so we like the idea of having, so we start with a seed list of censored URLs, and then we look at the content that's on those pages, so we go and we grab those pages, wget page, and then we look at the content, we strip out all the HTML and the JavaScript and stuff like that and see what is unique to those pages. And then we basically run search queries on those terms. So we run search queries on those terms, and then look to see if the pages that come back as search queries are themselves filtered. Then, if they are filtered, this is a recursive process, so we look at the queries on there, and we loop through the whole process again. So we've got this ever-expanding process of searching for the queries that we find on filtered pages, adding them back to our database, and then continuing the loop with an ever-expanding list of URLs that we know are filtered. But yeah, like I said, that's a bit simple, so we wanted to build it and show this kind of thing works. So we did that. And this is kind of our proof of concept. We needed to make a few kind of design choices to do this, to prove that it works. So first of all, we needed a method for sorting web page content. So we're using a statistical technique called TF-IDF, term frequency inverse document frequency. I'll talk about that in a sec. For a search API, we decided to use Bing via Zero Cognitive API. And for the censorship system, we're using China. They use DNS poisoning, and I'll talk a bit about that soon. So TF-IDF is this cool technique where basically it ranks terms on a page or terms in a document by the frequency they occur in indirect proportion to the frequency they occur on other pages and in other documents. So if something occurs a lot on one page or a lot in one document and infrequently on another page or another document, then those terms are ranked very highly. So that lets us find kind of tags and content that are very relevant to that page. There's a big advantage for us. When you're working in censorship, if you're looking at different systems in different countries, they all use different languages. Right? And as researchers and academics, we can't expect to speak fluently in tens of different languages. One of the nice things about this is it's language independent. So even if you don't understand the language, it's still picking out unique phrases to that page in contrast to other pages in the same language. So we needed to kind of configure the TF-IDF. So it's standard practice to ignore the most common words, it's standard practice to ignore the most common words. When we do our searching, we're looking for the 5 most common unique words or terms to that page, and then we're searching 50 results deep with each query that we do. So we're using Bing. There's some reasons for that. So Bing offer quite a nice usable API that can perform a lot of searches. So Google used to have an API, but they've deliberately gutted it a bit. One of the things they've deliberately done is set a hard limit on the amount of queries you can do per day. And our result, or our method, as you can imagine, is constantly churning through pages. It's producing a hell of a lot of searches, and so the Google limit is not large enough for the amount we need. The other thing is Bing is global, and apart from Google, they've probably got as much information as anyone on kind of web content. People ask, why wouldn't it be better maybe to use something like Beta or some kind of local search engine? But there's a big disadvantage there. So something you see in censorship, yep, some of it's done by kind of technological means, things like DNS poisoning or IP blocking, but at the same time, a lot is political pressure. An example of that, in Beidou, if you search for Tiananmen Square, you're going to get a massively different set of results than if you search for Tiananmen Square in kind of Google in Dublin. So there's the material you will look at if you're looking through Beidou is going to be very different than if you go through Bing. And so China. So why China? China is really well researched and understood. They've got a few layers of censorship and it's kind of changed over time, but a lot of it's done by this kind of quite naive DNS poisoning. And it's also got this really good property where it's really easy to check if something is censored in China. So DNS poisoning in China works by you make a request to an IP in China, or even if your IP kind of routes through China accidentally, you make a DNS request. Their infrastructure sees the DNS request. If it's for a filtered domain, it sends a response back with a poisoned IP. The interesting thing is, it will do this regardless of whether you're making the request to a legitimate DNS server or not. So that allowed us to kind of, we picked IP addresses where we knew there was nothing there. We made DNS requests to it. We could send hundreds of thousands of DNS requests to it, and we knew that we would only get a DNS reply back if it's a filtered domain. And for everything else where we weren't getting responses, we can be completely sure that their DNS poisoning isn't targeting them. There's also some other cool phenomena about this. It kind of accidentally poisons a lot of DNS queries around the world that kind of accidentally skirt around China or go through China. Even if you've got like top-level servers that aren't in China, sometimes it will route through and accidentally get poisoned by this infrastructure. So yeah, we built that and we ran it for a week earlier in the year, and these are the results really from that. So in that week we ran 54,000 queries. We found 1.1 million URLs. Of those, about 10% were filtered. And in that time we discovered 1,300 unique poison domains, which is larger than anybody else compiling these lists. That was about just over 4 domains for each 1,000 URLs that we queried, so it's quite a slow process, but grinding through it, it's quite a time-consuming process. So the most frequently occurring poison domains isn't really a surprise for anyone. So if you work in this field, you are aware that things like Facebook, YouTube, Twitter, Instagram, Google, these are censored in China. Well, there's nothing really exciting by that, and so all the pre-compiled lists have this kind of thing anyway. What our method was quite good at finding, however, was the kind of less common domains. Because we're using this search process and we're going 50 deep, we're finding a lot of domains that they're just not really considered. People aren't really looking for them, or they're often being ignored by automated processes. And so we could find a lot of these domains that nobody had really added to censorship lists. And we could use our process to confirm very quickly, or to find them and then confirm that they were censored. So we take these tags that are based on the web pages, and then we use them to find other web pages with similar tags. So there's a nuance here that I want to stress. It took me a while to get my head around. So we're not looking for censored keywords. Instead, we're looking for terms that appear on censored content. So it's kind of the same thing, but backwards. So what I'm not saying are pages with Trump and Obama are censored. That's not the case. But the fact is those words occur frequently in pages that happen to be censored. And yeah, so although and again, these aren't censored keywords, we still saw some interesting patterns there. So things like activist detention, protest leak, okay, there's nothing really surprising there. We saw a lot about VPN and kind of content evasioning technologies. So that kind of material often occurred frequently on censored sites. And then of course some of the kind of regional censorship stuff that I guess makes a lot of headline, things like Burma, Tibet, Dalai Lama, exile, things like that. And so they're quite interesting, even though we can't say that these are keywords that are deliberately targeted by censorship. They just happen to occur on censored sites. When going through this process, we thought it'd be interesting to look at what we call the discovery power of a domain. So this slide is quite boring, but makes a point. So look at YouTube, Twitter, Instagram. These are pages that have got a lot of content on. So what we're seeing here, let me explain it. Along the y-axis, we've got the descriptive tags on these pages, leading to filtered content. And on the x-axis, we've got the discovery power, which is the number of filtered URLs found by those tags. So as you can see here, this is quite linear. And the reason that is because these are big websites with a lot of content on, so it's unsurprising. You know, you go to YouTube, there's subjects about everything. So unsurprisingly, as you're crawling through these YouTube URLs, you find lots of different subjects, and they lead to lots of different censored content. That's not really interesting. But when we removed the larger sites, you tend to find websites with what we refer to as a high discovery power. So over here you've got youhereamerican.org. So it's got a low number of descriptive tags. That is, there aren't many. It doesn't have the wide variety of content that something like Facebook or YouTube does. Yet, for the tags it finds, it leads to a very high amount of filtered URLs. So the further along something is along the x-axis, the more the terms on there correlate to censored fields or censored terms in other URLs. So we ran this for a week in February, and we found quite a lot of poison domains compared to previous lists. So I should be clear, the Citizen Lab list, their list, they're not trying to make a comprehensive list, so there's a bit of an unfair comparison there. They're just trying to make a list. They're not trying to find every poison domain they can. That's the one we used as our seed list, and with that we found our 1,300. Previous work in this area was kind of the Sensmon paper, which was from Foci in 2011, and their method, they left it running and they found 176 poison domains. So we found far more than the previous work in this area. So to conclude, I've introduced our general approach for this content. We built it, we kind of developed this framework. We tested it on China because it had that cool, easy to test DNS poisoning thing, and then we performed a bit of analysis on that content. And again, I want to stress there is this difference between the framework and proof of concept. So since getting this paper accepted here, we've been working on adapting it to different countries. We've been quite successful with that. So right now, it was easy to get this tested on China because of that artifact of DNS. On other countries, we're having to do kind of more clever things like looking at the different analysis of web page content. So if they're not doing kind of neat DNS poisoning like this, we're having to basically crawl to two different web pages and look for the differences and look at it that way. But that said, we've had quite a bit of success so far applying this kind of broad methodology. You know, once we've tinkered with the details, but applying this broad methodology to other countries. And we've also run it a lot longer than a week. Thank you. That's it.
Will you be making lists available for different countries of the...
That's the plan, yeah. That's what we're working on right now. So we've got it successfully working on China, Indonesia, Turkey, and Iran.
Okay.
And so the nice thing is, like I was saying, some of those aren't simple just DNS poisonings. Using something like TF-IDF, we can apply it without having to do the local language. The hard part on our part is being able to distinguish between a legitimately censored site and something that isn't censored.
Okay.
And of course, you know, we know as we browse the web, the content is often dynamic anyway, so that's not always an easy decision to make.
Yep.
But so far, we've had a surprising amount of success doing that.
Okay.
So yeah, so on that topic, I mean, so your intent is to make the list you find public?
Yep.
And so presumably these are kind of a bit like kind of block lists and other things that people make, like an Indiana spam kind of community. And so something like come along to you and say, oh, by the way, this is not censorship, it's just a bug in your something, and take my name off that list?
Yeah, you're right, that's something we've not thought about, but yes. I guess for the China situation it's very easy because we can tell if something is being poisoned with 100% certainty. But you're quite right, yeah, if somebody wants to come to us, we'll have to make that available to them.
So yeah, I mean, I guess maybe talk to people like Spamhouse or something who have experienced this, because that's, you know, sometimes it will be a malicious person, sometimes it will be a genuine person that's asking to get off that list.
Yeah, that's a really interesting point.
Yeah.
would it be possible to, for example, last presentation like this exhaustive list of domains to just send all domains to the China DNS and check for all domains if they're being poisoned?
So in China's case, that's difficult. It also, the poisoning is a bit more granular than I mentioned. It does it on the subdomain level. So in a previous bit of research I did, we used passive DNS replication to basically look for reverse queries for. So a bit more background about Chinese DNS poisoning. Every time you make a request for a poisoned domain, it's quite nice in that it sends you to one of 11 different IP addresses. So what I did was basically perform reverse queries against those 11 IP addresses and then got a lovely list of domains that had been associated with those in the past. So we have got quite a long list of poisoned subdomains. But yeah, we've not actually thought about brute forcing through every different domain. I don't know if we'd have to do that on a subdomain level. I'll have to think about that. Thank you.
Yeah, question. So, from what I understood, the keyword that you use to extract your URL and so on are based on like kind of long-term censorship topics, right? Did you try to have like some kind of short-term events of censorship? I know that, for example, Turkey, they have some kind of blackout policy when there is an attack or something, but they will forbid the media to talk about something that is happening. And did you see any kind of events like this?
Yeah, well, so no, we've not. But I think that's one of the things about this approach is that it's language independent and it's deliberately not biased. You know, it's deliberately finding things that are censored regardless of anything else. So no, I don't know if we've looked at that. Another piece of work we were doing has kind of looked at fluctuating network traffic and Tor traffic in particular in response to those kind of censorship events. So we've got available online, you can, I can find you the URL after if you want. We've got, we're looking at kind of VPN, we're looking at censorship evasion tools, things like Tor and VPN and stuff like that, and looking for spikes in traffic when around censorship events like that. So you're quite right, most censorship events do tend to be quite short and spike in over a month. But no, I don't think we've really looked at this work in that context.
But maybe it should be available, right?
Yeah. So
certain terms should be like, I don't know how they actually block the.
Yeah. So kind of like resetting our list of tags periodically. That's a really good idea. No, thank you.
So did you see any HTTP 451 responses or?
I don't think we were looking for them.
Okay.
I think we were just looking for, we were just testing to see that DNS result to see if it was legitimate or not.
Okay.
So no.
Okay, yeah, but I'd be interested in how many censors actually sort of self-declare.
Yeah,
here's what I want to.
I don't know. I expect we did, but I expect they were just dropped by the script. I don't know.
Okay. Well, I guess we'll be interested. I mean, I assume it's early days for deployment, but interesting.
And like I said, that we've not seen much of that in China. You do tend to see it elsewhere, and that's where all the censorship is. The censorship systems are very, very different depending on where you look at. And so in China, that isn't really used as far as I'm aware.
You said that you weren't using badly because they already censored some content, but also you could argue that the right of to be forgotten at Google or is also some kind of censorship from some perspective.
Yeah, I almost mentioned that in my slide about different countries have clearly got different takes on what censorship is. In the UK, it's accepted now that we will censor pornography and pirated content, and that's kind of come in over the past 10 or 15 years. But yeah, EU-wide, you've got the right to be forgotten. Is that censorship? Is it not? It's a really interesting question. In the kind of strict sense of yes, they're kind of controlling the information that gets to the user. Then yes, it probably is. Is it okay censorship just because we consider it ethical? It's the deeper question.
But will you try? Are you planning to detect that as well?
Yeah. I don't think we're planning to look at right to be forgotten stuff specifically. No, but we are going to be applying this to the EU and European countries.
I guess the interesting thing is that operationally, the way you make your list becomes the definition of censorship for you, right? So if it's DNS poisoning, or if it's 451, or
and of
different
course,
vantage point differences.
And of course, there's missive things like search engine censorship anyway, because the whole process is using search engines. It wouldn't, I don't think, without major changes, how could it even be applied to that, unless you're comparing different search engines to...
Or about, I guess, multiple vantage points.
Yeah.
Yeah, but I assume you're planning to extend to multiple vantage points anyway, so...
Yes. Other than China, what method are you using to check whether the domain is actually blocked or not blocked?
So the main thing we're using right now is we're basically making a GET request to inside the country and outside the country. We're looking at the content and kind of doing a diff and seeing whether it's substantially different or whether most of the content is the same, maybe just the ads are different or different frames.
And how did you select the vantage points?
I do not know because I'm not writing the code for that.
Any more?